Hello there, and welcome. I'm glad you've drifted in tonight. Maybe your day has been long and the noise is finally fading, or maybe you're the kind of soul who finds comfort in strange, tidal thoughts, in rhythms that hum quietly beneath everything we know. Either way, you've arrived exactly where you need to be. You don't have to move, or fix, or solve. Just breathe. Let the air move in and out, like the slow pull of a tide beneath the moon. Because tonight, we're not looking up at the moon. We're listening to it. That pale companion hanging over the sea is more than a silent light. It's a sculptor, a timekeeper, a restless conductor pulling at the edges of the world. The moon moves entire oceans with nothing but gravity and grace. It shapes coastlines, guides migration, and even stirs the heartbeat of the planet itself. As you rest, we'll explore how something so distant can hold such quiet power. This is not just about tides. It's about the invisible thread between Earth and its oldest mirror, the moon. Now take a deep breath. Let your day drift away, and let's travel together into the quiet corners of the universe. Far out in the dark, the moon hangs in silence, pale and patient, its face turned toward us as it has been for billions of years. It does not shine with its own light. It reflects what it borrows, a cold glow borrowed from the sun and sent softly down across the sea. Yet that quiet light is not its greatest influence. What truly connects us to the moon is something deeper, invisible, and unbroken. Gravity. It is a pull so gentle that you cannot feel it, yet powerful enough to move entire oceans. Every drop of water on Earth feels it. Every wave that folds and unfolds against the shore is, in part, the echo of that celestial tug. Imagine standing at the edge of the sea on a calm night. The tide seems still, the air heavy with salt and sound, but beneath the surface, the entire ocean is rising. The moon's gravity stretches the Earth itself, pulling water toward it, creating a vast, slow bulge that follows its motion through the sky. On the side facing the moon, the sea swells upward, chasing the invisible hand that calls it. But on the opposite side of the planet, something stranger happens. The water there, too, lifts, pushed outward not by attraction, but by inertia, the Earth moving slightly away from its own oceans as the moon's gravity tugs the planet's center. Two tides born of one pull, mirrored across a spinning world. Every day, as the Earth turns, we move through these invisible hills of water. To us, they seem like ordinary tides coming in and out, but from above, they are slow rivers of motion sliding across the globe, wrapping it in rhythm. The moon does not pull and release in short breaths. Its influence is constant, steady, almost tender. The oceans flow beneath it like silk drawn between fingers. The force is ancient and patient, having shaped the seas long before life rose from them. This pull is not uniform. The moon's gravity is strongest on the side, nearest it, weaker on the far side. That difference, barely measurable by instinct, but absolute in physics, is what creates the tide's rise and fall. It's a delicate imbalance that never ends, a dance between mass and motion. The Earth rotates beneath this gradient, and the oceans, unable to keep perfect pace, lag slightly behind. This friction between water and rock, between motion and pull, transfers energy. The Earth slows by tiny fractions of a second each century, and the moon, in turn, drifts away by a few centimeters each year. The tides are not just waves. They are a form of time, stretching the seconds of our days and the distance of our orbit. When the moon hangs directly overhead, its pull reaches its greatest strength, and the tide below swells to meet it. The line where the sea touches the shore creeps forward in silence. It's easy to think of this as water moving, but in truth, the entire planet is shifting shape. The land flexes, ever so slightly, under the same pull that stirs the deep. Even the solid crust rises and falls by centimeters, the Earth breathing in rhythm with its satellite. For all its grandeur, this is a relationship built on balance. The Earth's rotation tries to carry the tidal bulge ahead, but the Moon's gravity resists, keeping it just offset, like a dancer's lead held firm. The push and pull exchange momentum, binding the two bodies in an invisible current of energy. The Moon, distant and aloof, is not just circling us. It is tethered, its path and our spin locked together in a slow evolution written in gravity's quiet script. If you could stand above the world and watch, you would see the oceans moving not as chaos, but as harmony. Vast sheets of water rise beneath the Moon, slide across continents, and fall away again, always chasing equilibrium. Coastlines glow faintly in the light, each one marking the edge of a gravitational melody. The tides come not because of storms or winds, but because the Earth is never still. It is stretching, breathing, pulled, and released in a motion older than memory. As the Moon crosses the sky tonight, its influence travels through every bay, every inlet, every shallow and deep. The sea lifts beneath its gaze and subsides again when it moves on. The same pulse repeats tomorrow, and the day after that, and every day until the Moon drifts too far to hold us so tightly. For now, though, we remain bound. The pull continues, unseen and unstoppable, shaping the rhythm of the planet and the quiet heartbeat of the sea. If you could peel back the clouds and look down on the Earth from above, you would see the oceans breathing in slow symmetry, two bulges of water forever chasing the Moon, one rising beneath its glow, the other swelling on the far side of the world, where the Moon's light cannot reach. This is the secret of the twin tides, a balance that seems impossible at first, yet unfolds with quiet precision. Every shore, every inlet, every grain of wet sand participates in this planetary rhythm, pulled first one way, then the other, as the Moon and Earth turn in their silent waltz through space. The tide that faces the Moon is easy to imagine. The Moon's gravity draws the sea toward it, lifting the water slightly higher, as if the ocean were leaning up to meet its pale reflection. But what of the tide on the far side, where the Moon's pull is weakest? That tide rises for the same reason a dancer's skirt lifts when she spins, because motion itself creates its own kind of pull. As the Moon's gravity tugs the Earth's center, the planet shifts minutely within its ocean shell. The water on the far side, less bound by the Moon's force, lags behind and bulges outward, flung gently away by the momentum of the Earth-Moon rotation. Two tides born from one pull and one push, opposite yet equal, like the inhale and exhale of a single breath. This constant stretching turns the Earth into something more like an ellipsoid than a perfect sphere. The oceans elongate slightly along the line connecting our planet and its satellite. The Earth rotates beneath this stretched cloak of water once every 24 hours, sweeping each bulge across the globe. To those of us standing on the shore, this cosmic geometry becomes the familiar rhythm of tides coming in and out, though what we witness is only a glimpse of a much larger motion, one that spans continents and centuries. The Moon doesn't circle above the same points each day. Its orbit tilts and slides, drifting eastward as the Earth spins. The tidal bulges follow it faithfully, but never perfectly. Friction with the seafloor, the drag of continental shelves, and the push of winds and currents all conspire to delay them, just enough that they lean slightly ahead of the Moon's position in the sky. That small offset is the whisper of energy being exchanged. A slow trade between the Earth's spin and the Moon's orbit. The Earth gives a little of its rotation away, and the Moon takes it, inching farther from us, its path widening over eons. This exchange is invisible to us, but its effects ripple through time. Each day grows a fraction longer, each night stretches infinitesimally wider. The Earth is aging in rhythm with its tides. Long after our lives have ended, the oceans will still be moving to this same lunar tempo, carrying the memory of every shoreline that ever was. In the heart of this system, nothing truly stands still. The bulges slide endlessly around the planet, shifting energy, redistributing weight, brushing against continents like the sweep of a giant hand. The tides seem calm, but they are expressions of profound motion, an entire planet flexing under the subtle grip of a distant companion. The moon does not command with noise or light, only with gravity, the most patient force in existence. And yet, for all this movement, there is a deep stillness at the center of the dance. The earth and moon are locked together by gravity's quiet thread, each shaping the other. The same force that lifts the seas also keeps the moon facing us with one unwavering gaze, as though it too were caught in the spell of the oceans it stirs. Two bodies, bound by an ancient rhythm, circling endlessly through the dark. If you listen carefully on a calm night, you can almost hear it. The slow rhythm of the twin tides rolling through time, the steady heartbeat of a planet caught between pull and release. The ocean moves, the earth turns, the moon drifts away, and still the balance holds. Two tides, two halves of one breath, moving endlessly beneath a sky that watches but never interferes. The earth does not spin as steadily as it once did. Long ago, when the world was young, and the moon still hung close and bright in the sky, our planet turned faster. Days were shorter then, barely 6 hours long. The oceans rose and fell with furious speed, pulled by a moon that loomed 3 times larger than we see it now. Over billions of years, that rhythm has softened. The tides have become gentler, the nights longer. The same force that stirs the sea has been quietly changing the tempo of the entire planet, slowing its spin one heartbeat at a time. Each tide that surges across the continents leaves behind more than the mark of water. It drags faintly against the seafloor, rubbing at the edges of continents, transferring energy from Earth's rotation into motion elsewhere. The friction is invisible but relentless, a planetary brake that never releases. As the Earth spins, the tidal bulges try to align with the moon, but they can't keep up. The rotation carries them slightly ahead, creating a subtle imbalance that pulls on the moon, nudging it forward in its orbit. It's a slow exchange, gravity passing energy from one partner to the other. The Earth loses a little of its momentum, and the moon takes that momentum for itself, climbing outward inch by inch. Each year, it drifts about 4 centimeters farther away, an almost imperceptible retreat that has been happening for billions of years. The moon is leaving us. Not abruptly, not dramatically, but faithfully, in accordance with the same physics that bound it to us in the first place. And, as it drifts, the Earth slows in response. The days grow longer by tiny amounts, so small that only the most sensitive instruments can measure them. Yet over ages they accumulate. Centuries from now, our clocks will tick a little differently, our sunsets arriving just a breath later. The oceans, meanwhile, continue their endless conversation with the moon. With every rise and fall, they whisper energy back and forth, sculpting coastlines and shaping time itself. The tides do not simply mark the passage of hours, they manufacture them. The moon's steady theft of energy from Earth is what gives us the precise length of a day as we know it. Without that drag, our planet might still spin in a dizzying rush, the stars wheeling overhead too quickly to follow. The slowing gives us rhythm, order, a pace gentle enough for life to adapt and flourish. If you could stand on a beach at night and see this exchange unfold, it would look almost motionless. The moon would hang where it always does, serene and familiar. The ocean would breathe softly against the sand, but beneath that calm surface, the entire planet is flexing. The continents are shifting under the weight of the tides, the core turning fractionally slower than before. It's as though the Earth itself exhales with every tide, surrendering a fraction of its spin, a fraction of its energy, to the silent companion circling above. This slow trade has been recorded in the rocks. Ancient corals, frozen in limestone, carry the imprint of faster tides from long ago. When scientists count the growth rings inside them, they find evidence of more days in a year, 400, sometimes more. The days were shorter because the Earth turned faster, and the moon was closer, pulling harder. Each layer of coral is a fossilized calendar, proof that time itself has stretched under lunar influence. There's something tender in that inevitability. The moon is not a thief but a partner, taking what is freely given, shaping the balance that allows both to endure. Its distance preserves our stability. Its pull maintains our oceans, our seasons, our sense of home. The slowing spin of the Earth is not decay, it's evolution, the deep rhythm of a system learning to sustain itself. And though we cannot feel it, the exchange continues even now. The moon climbs higher, millimeter by millimeter, and the Earth turns ever so slightly slower. Someday, long after our species is gone, the two will reach equilibrium. The Earth's rotation will match the moon's orbit perfectly, locked together in a permanent embrace. The same face that looks down on us tonight will still be there, frozen in place, the tides calm, the energy balanced, the dance complete. Until then, the Earth sways on, its pace measured by tides, its motion tuned by gravity's gentle persistence. The moon glides outward, carrying with it the memory of the world's faster heartbeat, of shorter days and wilder seas. What remains is the rhythm we live within, a quiet slowing, a cosmic breath drawn over eons, a reminder that even in stillness, the universe is moving. If you listen long enough, you can almost hear it. The soundless breathing of the sea, not the crash of waves or the whisper of foam against sand, but a deeper pulse, a rhythm that moves beneath the surface and spans the entire world. The ocean inhales and exhales in time with the moon. With every rise of the tide, the waters pull outward, stretching the lungs of the planet wide. With every retreat, they sink back, pressing the air, the pressure, the very weight of the world inward again. This is not a metaphor. It is motion made real, a planetary respiration written in water and gravity. The tides are the heartbeat of the sea, but they are also its breath. When the moon draws the ocean upward, it does more than move water. It alters the balance of temperature and pressure across the planet. Along coasts and continental shelves, cold water from the deep is lifted to the surface, bringing with it nutrients and minerals that have been sleeping in darkness for centuries. This upwelling feeds plankton blooms, and the plankton feed everything else. Fish, whales, seabirds, even the oxygen we breathe. In this way, the moon's gentle pull sustains life we will never see. It keeps the great cycles turning, unseen and constant, beneath the illusion of calm. When the tides retreat, the ocean exhales. The surface warms under the sun, and the layers settle back into their gradients, warm on top, cold below. The nutrients drift downward again, stored in the deep for the next breath, the next pull. The whole system functions like a slow, immense lung that never stops working. It is why the sea does not stagnate, why its chemistry remains alive, why its creatures can move across vast distances and still find nourishment in seemingly empty water. Even the air above responds. As tides rise, air pressure shifts subtly over the ocean's skin. Moisture gathers differently, winds adjust, and temperature gradients ripple outward. Meteorologists can measure the faint signatures of the moon in the patterns of weather, the smallest oscillations in humidity, in pressure, in the tilt of the atmosphere's balance. The moon's influence extends farther than light can reach, touching the invisible boundaries between sea and sky. To stand near the coast during high tide is to be near the ocean's inhale. You can feel it in the salt thick air, in the coolness that rises from the water, in the stillness that precedes the next retreat. The moon above may look silent, indifferent, but beneath its light, the entire biosphere is in motion. Every bay, every reef, every drifting current is participating in a single, continuous act of exchange. This breathing is not confined to the surface. Deep currents, slow rivers of water, thousands of meters below, shift as the moon's gravity moves across the planet. In some regions, tidal energy pushes dense, nutrient-rich water upward through canyons and over ridges, turning barren depths into hidden gardens. In others, it pulls warmth down, stirring the stratified layers that would otherwise grow still and lifeless. Scientists call this process tidal mixing, but it is more than that. It is renewal. Without it, the ocean would separate into silence. Warm water above, cold below, life trapped between. The breath of the ocean is what binds its parts together. It links polar ice to tropical shallows, coral reefs to open trenches, surface winds to deep currents. The moon doesn't just lift the tide, it maintains the pulse of global circulation, the quiet choreography that redistributes heat and nutrients across the world. The same forces that raise a tide in one place send echoes of movement halfway around the planet. It's humbling to think that something so small in the sky governs something so vast. The moon cannot speak, yet it commands the rhythm of oceans. It has no atmosphere, yet it stirs ours. Its gravity is steady, predictable, and ancient, but what it creates is always in flux, a perpetual motion that never ends, never tires, never loses grace. At night, when the tide is high and the wind drops to nothing, the world feels suspended between breaths. The sea holds still for a moment, as if listening for its own heartbeat, waiting for the moon's next instruction. Then the water begins to move again, quietly, inevitably, drawn outward by that distant pull. The ocean inhales once more, and the earth exhales. Long before clocks or calendars, before hours were carved into metal or marked on glass, time lived in the sky. The moon was its keeper. Early humans watched it swell and fade, counted its return, and found in its rhythm a language older than numbers. Each phase was a chapter of light and shadow, a cycle of growth and retreat that mirrored the rise and fall of tides, the turning of seasons, the heartbeat of the world. The moon was not a symbol then. It was a clock that glowed. It told them when to plant, when to hunt, when the waters would rise and the fish would come close to shore. Even now, hidden beneath the neon hum of cities, that same lunar rhythm still hums quietly within us. In the coastal shallows, coral colonies time their great release to the moon's pulse. Once a year, under a full moon, millions of polyps open together, releasing tiny luminous spheres into the water. A synchronized bloom of life that can be predicted down to the night. The coral do not see the moon, but they feel it. Its light filters through the water, its gravity tugs at the sea, and their bodies respond, guided by an ancient clock, wound not by gears, but by the pull of celestial timing. This rhythm echoes through the animal kingdom. Grunion fish that surge onto beaches to lay eggs under a new moon, sea turtles that hatch in the dark to meet the receding tide, and nocturnal predators that hunt when the lunar light is just enough to see but not enough to be seen. Even plants, anchored and silent, respond. Some trees open their flowers only during full moons, aligning their scent and pollen release with the activity of nighttime pollinators that follow the same lunar glow. The moon, without sound or intention, organizes the living world through repetition. It is the quiet metronome of nature, invisible yet universal, dictating the tempo of survival itself. For early humans, the moon became a companion in that rhythm. They marked their lives by its cycles: new moons for beginnings, full moons for gatherings, waning moons for endings. Many of the world's oldest words for month come from moon. It shaped language and myth as much as it shaped time. When people saw the moon vanish into darkness, they didn't fear loss. They recognized pause, rest, the interval between one heartbeat and the next. In its return, they saw renewal, the reassurance that the world was still turning, still breathing. The moon didn't just measure time, it gave time meaning. And though we've built clocks so precise they can measure billionths of a second, our bodies have not forgotten the moon's slower rhythm. Human sleep cycles subtly shift with its phases. Studies show that in the days before a full moon, people tend to fall asleep later and sleep less deeply, even in sealed rooms without windows. Somewhere deep within our biology, a memory remains of nights lit by a brighter sky, of tides surging in the blood, of a connection that predates consciousness itself. Women's reproductive cycles, though not bound by it, still average close to the lunar month, a resonance of timing older than culture, perhaps older than humanity. Time itself is tidal. Just as the moon pulls on the ocean, it pulls on the fluids, the hormones, the internal rhythms that keep our lives in balance. In the modern world, we live by artificial light and digital precision, but the lunar clock still ticks quietly underneath. The corals still rise with it. The tides still bend to it. The wolves still lift their heads when the light returns, and we, even if we've forgotten why, still pause to look up. The moon's grip on time is not just about measurement, it's about continuity. Every cycle is a reminder that endings are temporary, that stillness is only the breath between phases, from the coral reefs to the pulse in your wrist, from the earliest shadows on cave walls to the glow of city skylines. That rhythm persists. It hums in the background of existence, patient, steady, and eternal. The moon has been marking time for as long as there has been anything to mark. And though we chase seconds and calendars now, the oldest clock in the sky still keeps its own perfect beat, moving not by machinery, but by the pull of the earth itself. Far below the sunlight, where no color survives and pressure crushes anything unprepared, the ocean still moves. It does not sleep, even there in the blackest depths. Beneath the calm surface and the endless blue, there are rivers that rise and fall with the moon, hidden currents that slip through the deep like slow, soundless breath. They are invisible to the human eye, but their touch is everywhere. The tides, which we see only at the shore, do not stop when the water grows dark. They reach down, pressing against the ocean floor, tugging at the shape of the world itself. When the moon pulls on the sea, it lifts not just the surface, but the entire column of water from top to bottom. That movement may be only a few centimeters in the deep, but across thousands of miles, it becomes a force of unimaginable scale. As tidal waves travel over undersea mountains, ridges, and trenches, they stir the abyss. Dense, cold water is lifted upward, and lighter water is pushed down. It is a quiet, churning, a slow blending that keeps the ocean alive. Without this mixing, the deep would stagnate, starved of oxygen and warmth. Life below would wither in stillness. The moon's pull sets these hidden tides in motion, and the Earth's shape guides their path. Along continental slopes and seamounts, tidal energy gathers like wind against a cliff, breaking into turbulence that spills downward in invisible waterfalls. These cascades carry nutrients from the dark into regions where they can rise again, fueling microscopic life that feeds the chain above. Even the smallest creatures, plankton drifting near the surface, owe their survival to this deep exchange. What the moon stirs in silence becomes the breath of the sea. In the Mariana Trench, deeper than any mountain is tall, scientists have detected faint oscillations in temperature and current, matching the rhythm of the tides above. Every 12 hours and 25 minutes, the deep water sways. It is not much, just a few millimeters of movement, but in that slow rocking, heat and matter are exchanged. The ocean's deepest scars are not still, they pulse with lunar time. This unseen motion links the surface to the abyss, uniting every layer of water into a single organism shaped by gravity's whisper. Where these hidden tides collide with the rugged topography of the seafloor, they create internal waves, vast, invisible undulations that move not along the surface, but through the body of the ocean itself. Some of these waves are hundreds of meters tall, yet they pass unnoticed above. They roll through density layers like ghosts, breaking and reforming, stirring the dark with delicate precision. For every visible wave that crashes on the shore, Thousands more ripple through the deep unseen, sculpting temperature, motion, and the boundaries between life and void. This endless stirring helps balance the planet. The mixing of deep and shallow waters redistributes carbon, heat, and nutrients across the globe. It prevents the deep ocean from growing cold and lifeless, ensures that oxygen from the surface finds its way to the bottom, and keeps the carbon from decomposed life circulating back into the system. Without it, the ocean would become stratified, a world of layers that never touch, a place of isolation instead of connection. The moon, without knowing, prevents that. It keeps the ocean breathing, even in its loneliest depths. Imagine standing at the edge of the sea during high tide. You see the waves inch forward, slow and deliberate, but what you do not see is how that same pull reaches down through miles of water, bending the deep, moving continents of liquid in ways too vast to comprehend. Every grain of sand beneath the waves, every drifting current of plankton, every whisper of silt stirred from the floor, is part of this cosmic motion. The moon and the earth are locked in an eternal exchange, and the ocean is their medium. The deep currents never stop. They move day and night, in darkness and in light, through storm and stillness. They are patient. They are ancient. They are the unseen heart that keeps the ocean alive. And as the moon continues its slow orbit, tugging ever so slightly on the edge of gravity, the world below continues to respond. A pulse, a sway, a breath. He felt nowhere on the surface, but heard everywhere in the bones of the sea. Along every coastline on earth, something ancient and patient is at work. It does not rush, it does not rest, and it never stops. The moon's pull, soft and invisible, reaches across the planet and touches every grain of sand, every cliff, every inlet and bay. Each tide is a gentle rearranging of the boundary between land and sea, and though a single wave may seem fleeting, the sum of all tides, the daily breathing of the ocean under the moon's command, slowly reshapes the world itself. From above, coastlines seem permanent, lines drawn confidently between blue and green. But if you could speed up time, compress centuries into seconds, you'd see them flicker and shift. Bays deepen, cliffs retreat, beaches migrate with the seasons. The edge of the continent is alive, sculpted by water that moves not of its own accord, but in obedience to a faraway companion circling the night. The moon does not simply light the ocean, it draws it upward, sideways, inward, again and again, grinding the edges of the world into new forms. When the tide rises, it seeps into cracks and crevices of stone, pressing with weight and patience. Salt water enters the pores of rock, leaving behind crystals that expand when the sun returns and the sea withdraws. Over years, that quiet cycle of swelling and retreat turns cliffs to dust. The same force that lifts the ocean to the stars also pries continents apart, one invisible gesture at a time. The moon is the world's slowest sculptor, its chisel made of water and time. Rivers deliver their gifts to the tide, sediment from mountains, silt from plains. And where those waters meet the sea, the moon takes over. Each rise and fall pushes and pulls, spreading the river's burden into sprawling deltas. The Ganges, the Nile, the Mississippi. Each mouth tells the story of lunar rhythm. With every cycle, the moon smooths the sharp edge of land into soft complexity, braiding channels and islands into the skin of the earth. Deltas breathe in time with the tide. They grow and collapse, build and erode, like lungs inhaling silt and exhaling to the sea. Along rocky shores, the same pulse creates power. Tidal surges funnel into narrow inlets, racing against themselves, carving smooth corridors into stone. Sea stacks rise where cliffs once stood, arches form and crumble, caves echo with the moon's rhythm. Even the gentlest tide carries the memory of this motion, in times the repeated gesture of pull and release, sculpting form from endurance. Every coastline you know is a momentary shape in an endless act of creation. Over millennia, the moon's influence reaches further inland than the eye can see. As tides drag sediment back and forth, they redistribute the weight of the oceans themselves, ever so slightly flexing the crust beneath. Continents respond in kind, rising or sinking under the shifting load. Shorelines migrate, islands appear, then drown. What seems like stability is only pause. The Earth's edge is a living border, written by the gravity of another world. Even ecosystems follow the moon's hand. Mangroves breathe in rhythm with the tide, their roots alternating between air and water. Crabs time their journeys to the moon's phases, knowing when to feed and when to hide. Tidal pools fill with trapped worlds, tiny galaxies of coral and anemone that bloom, vanish, and return. The moon does not only shape stone, it choreographs life itself along the water's edge. At night, under a full moon, the sea glows and the boundary blurs. The surf reflects silver light as if the two were in conversation, the ocean whispering back to its maker. Standing there, at the edge of the moving world, you can almost feel it. The slow pull of time, the moon's long patience, the ancient sculpting of continents beneath the sound of waves. The shore has never truly belonged to the land. It belongs to the tide, and the tide belongs to the moon. When the moon lifts itself over the horizon, the ocean changes. Its surface brightens into glass, and the creatures below begin to move as though something ancient has whispered to them. Moonlight, soft and silver, does more than illuminate the water. It organizes it. It gives the living world a signal, a pulse, a pattern to follow. The same light that glows across the surface filters down into the sea, scattering and fading until it becomes a shimmer, barely visible to the human eye. But to the creatures who live within its reach, it is everything. It tells them when to rise, when to feed, when to find each other. For coral, the moon's light is a calendar. On a precise night each year, when the water is warm and the full moon hangs high, coral colonies across entire reefs release their eggs and sperm together into the sea. Millions of tiny orbs drift upward in unison, glowing faintly beneath the surface like a reversed snowfall. The synchronization is so perfect that divers describe it as a single living breath. Scientists have found that corals sense the lunar light through proteins that act like clocks, tuned not just to daylight but to the rhythm of the moon. It is the oldest symphony on Earth, life keeping time to reflected sunlight. Farther along the shore, another miracle unfolds. Under the same full moon, sea turtles crawl from the sand, newborn and frantic, their shells still soft from the egg. They do not hesitate or wander. They move toward the brightest horizon, toward the reflection of the moon on the waves. That pale shimmer is their compass, their first guide in a world they have never seen. Each hatchling follows it to the water where the tide waits to carry them away. Even decades later, the females will return to the same stretch of sand, guided again by forces beyond sight. By magnetism, yes, but also by memory and light. The moon's glow even touches the smallest lives. In tropical waters, countless plankton drift near the surface, each one capable of creating its own faint light. When disturbed, they flash blue-green, a chemical spark known as bioluminescence. But under certain lunar phases, they seem to respond differently, as if the moon's brightness above the waves governs their glow below them. During the darker nights of a new moon, their light flares brighter, easier to see. The sea becomes alive with motion, a quiet galaxy of microorganisms blinking in rhythm with the Earth's satellite. It is as if the absence of the moon's light above invites its imitation below. Moonlight shapes behaviors we rarely notice. Some fish time their migrations to its brightness, schooling in safer numbers when the sea is lit and scattering into the depths when the night turns dark. Crustaceans and worms rise from the sand only under certain phases. Their lives sync to cycles written not by the sun, but by the lesser light that rules the tides. Even the predators have learned the pattern. Sharks and dolphins adjust their hunts to the moon's glow, knowing when their prey will rise closer to the surface. To stand by the sea on a full moon night is to witness this orchestra in motion. The tide moves higher, silver veins tracing the shore. In the shallows, corals open. In the air, seabirds stir. The water glitters with plankton light, a reflection of the stars above. It's hard to tell where the sky ends and the ocean begins, because in this moment they are bound by the same illumination. The moon's light travels across 250,000 miles of empty space, touches the sea, and is returned to the heavens as a shimmer, a faint gleam of acknowledgement. In between, life moves according to its rhythm. The same light that once guided ancient sailors now guides turtles, fish, and coral. It threads through the ocean like a quiet song, inaudible but unmistakable. Even when clouds hide it, the creatures remember. The cycle continues, measured not just in tides or days, but in the soft silver presence that has never failed to return. The moon does not command with power or noise. It simply shines, and the world beneath it listens. Before there were forests or wings or voices, there was water. The world was ocean then, stretching unbroken under the same moon that still watches us now. Its pull was stronger in those days. The moon hung closer, its gravity fierce, its tides immense. Twice each day, the sea rose and withdrew with power enough to strip whole coastlines bare. Where the water met the land, it left behind a chain of shallow pools, small worlds, cut off and remade with every tide. And it was there, in those shifting margins, that life began to change. Each tide was a cycle of opportunity and danger. When the water flooded in, it brought warmth, nutrients, and motion. When it retreated, it left creatures stranded in fading pools that warmed under the sun, rich in minerals and possibility. The moon was sculpting not just the planet's edge, but the conditions for creation itself. Within those temporary worlds, chemical reactions accelerated. Molecules met that would never have touched in the open sea. Cells adapted to dryness, to pressure, to fluctuation. Some learned to endure until the next wave returned. Others evolved to move, to crawl, to seek the water that once came to them. The earliest life lived in the rhythm of that lunar breath. Simple organisms floated through tidal shallows, their survival dependent on the moon's gentle violence. Each retreat of the water was both loss and invitation, forcing life to innovate. The alternating wet and dry cycles concentrated organic matter, allowing complexity to form molecule by molecule. Where oceans were vast and diluted, the tidal pools were intimate, tiny crucibles of change, small enough for life to experiment. It was there that evolution's first whispers took shape, guided by the same gravitational hand that still lifts the sea today. The moon's pull gave the earth its heartbeat. It stirred the oceans, moved nutrients through the shallows, and created a rhythm for biology to follow. Even now, that rhythm persists within living things. The cycles of light and darkness, of ebb and flow, have woven themselves into our cells. Circadian rhythms, hormonal tides, patterns of sleep and growth, all of them echoes of that first lunar pulse. We are creatures born from motion, descendants of a world that learned to live by the sea's breath. As the tides continued, their endless oscillation, they sculpted more than landscapes. They carved the boundaries between habitats, creating stepping stones from one world to the next. Tidal flats became transitional zones, half land, half sea, where creatures could test new ways of being. Primitive fish with strong fins and lungs ventured into the mud to escape predators or to feed on what the retreating water left behind. The moon, indifferent and constant, pulled the water away and then returned it again and again, teaching life to adapt to uncertainty. What began as survival became transformation. Fins became limbs. Gills began to share their labor with lungs. The first footsteps on land were imprints of the tide's legacy. The connection between moon and life is not metaphor. It is history. Every living organism carries traces of that origin story. Our blood holds nearly the same balance of salts as seawater. Our biological clocks still recognize the moon's cycle, even if our minds no longer notice. We are not separate from the tides. We are made of them. The same rhythm that once coaxed single-celled creatures to evolve still moves invisibly through us. Imagine that first creature standing at the edge of the ancient sea. Behind it, the moon's reflection ripples across the water. Ahead, a landscape unknown. The air is heavy, the sand slick, the pools behind it cooling as the tide recedes. It hesitates, feeling the pull of both worlds, the safety of the ocean, the promise of the shore. In that moment, the moon is there too, watching, guiding the tide that made such hesitation possible. Life takes one breath of air, and everything changes. The moon did not create life, but it gave life rhythm. It gave the sea its tides, the shore its pulse, and the first organisms the space to imagine something beyond water. Every wave that breaks on a modern beach is a reminder of that beginning, of the countless generations that followed the same gravitational script. The shore remains, a place of transformation, because it always has been. The moon still writes across the ocean in light and motion, sculpting the boundary between what is and what might be. It still pulls at the planet's waters, stirring not only the tides, but the quiet memory in all living things, a memory of pools that shimmered in lunar glow, where the earth first began to breathe. The ocean remembers everything. It remembers the pull of the moon when it was nearer, the rhythm of tides that once rose higher and fell harder, the warmth of ancient suns and the shadows of vanished continents. Every wave that retreats leaves behind more than foam. It leaves a trace, a pattern pressed into sand or stone, an echo of a moment that will outlive us all. The ocean keeps its memories in layers, each one a page written in salt and silence, a record of the world as it was. If you walk along a beach at low tide, the patterns in the sand seem temporary. Ridges ripple outward from where the water withdrew, catching the light like skin or breath. Within hours, they will vanish under the next surge of waves, erased and rewritten. But in some places, those ripples never disappear. When tides covered ancient shores millions of years ago, their shapes were preserved beneath layers of sediment, pressed into rock, fossilized in exquisite detail. These patterns, still visible in cliffs and deserts, are the fingerprints of forgotten tides, proof that the moon's pull has been writing across the earth since before anything with eyes could watch. In these fossilized ripple marks, scientists can read time itself. The spacing and orientation of each ridge tells the story of how fast the water moved, how deep it was, and even how strong the moon's gravity might have been then. The moon is slowly drifting away from Earth, its pull weakening with distance, and so the tides it raised in the past were stronger. In sandstone beds 500 million years old, the rhythm of ancient tides can be measured, revealing that the moon once hovered tens of thousands of kilometers closer. The Earth spun faster then. Days were shorter. Nights were younger. The ocean, in its patient record-keeping, remembers all of it. But the ocean's memory runs deeper than fossils. Every layer of sediment on the seafloor is a journal entry written by time. Dust from deserts, ash from volcanoes, the shells of plankton and the remains of storms, all settled gently in thin, distinct sheets. Each layer carries chemical clues, the isotopes of oxygen that record temperature, the ratios of carbon that tell of life and decay, the faint signatures of meteor impacts and magnetic shifts. The tides carry these particles far and wide, arranging them according to the moon's rhythm, building an archive so vast it could tell the story of every age of Earth. In the quietest depths, where no current disturbs the bottom, these sediments lie undisturbed for millions of years. Scientists drill into them, pulling up long cylinders of mud that read like history in cross-section. Within them are traces of vanished coastlines, of sea levels that rose and fell with glacial breath, of mass extinctions and recoveries, of epochs that began and ended as silently as tides. The moon's influence, though never recorded directly, is woven through it all. The gentle metronome that kept the oceans moving, kept nutrients circulating, kept life evolving through endless cycles of change. Sometimes, on certain coastlines, you can still see the tides etched into stone with eerie precision. Ancient tidal flats frozen in place. The ripples look so fresh that you could run your fingers across them and almost expect to feel the retreating water. But they are older than mountains, older than bones. They belong to worlds where trilobites scuttled and the moon loomed larger in the sky. Standing before them is like looking at a photograph taken by the earth itself, one that captures motion so slow that only rock could remember. The ocean never forgets, but its language is subtle. It speaks in erosion and deposition, in the rhythm of waves and the tilt of shorelines. It tells us that memory is not always stored in living things, that sometimes it's carved into the bones of the planet. Each tide that moves across the sea today writes another fleeting sentence in that ongoing story. Some will be lost, some will harden into permanence, but all belong to the same narrative that began when the first tide stirred under the moon's gaze. And though we cannot see it, the ocean continues to record us too. The dust of our cities, the heat of our climate, the noise of our ships, all sink into its memory. Someday, long after we are gone, someone or something may read those layers and know that we were here, that the moon still pulled at our world, that the tides still wrote their lines across the edges of time. The ocean remembers because it must. It is the Earth's oldest witness, and the moon its oldest pen. There are places on Earth where the moon's pull is not just felt, it is magnified, turned into something vast and thunderous. These are the resonant coasts, where water moves to the same rhythm as the moon's orbit, and the tides swell beyond reason. Here, gravity finds harmony with geography. The result is not a gentle rise and fall, but a living pulse that reshapes the land twice each day. It is not magic, though it feels like it. It is resonance, the same principle that makes a voice vibrate a wine glass, except the glass is a bay, and the note is struck by the moon. The Bay of Fundy, nestled between Nova Scotia and New Brunswick, holds the record for the highest tides on Earth. In some places, the difference between low and high tide exceeds 16 meters, enough to submerge a 5-story building. At low tide, the bay becomes a mudflat stretching to the horizon. Hours later, it transforms into a sea of roaring energy, the water rising so fast that boats moored to docks seem to climb invisible stairs. The moon does not pull harder here than anywhere else. What makes Fundy extraordinary is that the length and depth of the bay perfectly match the natural period of the tides. Every 12 hours and 25 minutes, the time it takes for the moon to return to its position overhead, the water sloshes back and forth within the bay like liquid in a bowl. Each new tide arrives just as the previous one rebounds, amplifying the motion until the entire body of water moves in unison. This is resonance made visible, a cosmic duet between gravity and geography. If the bay were slightly shorter or deeper, the timing would fall out of sync, and the tides would weaken. But here, the moon's rhythm and the Earth's shape align perfectly, creating a natural amplifier for the sea. The same principle explains why some harbors experience dramatic surges while others barely notice the tide. It depends on length, depth, and the contours of the coastline, how the water's oscillation fits the beat of the lunar cycle. The world's oceans are full of these quiet instruments, tuned by accident of geology and played by the steady hand of gravity. When the tide rushes into the Bay of Fundy, it does not simply fill space, it builds energy. Water accelerates through narrow channels and around headlands, forming whirlpools and standing waves that can be seen from the air. In the Minas Basin, the force is so strong that the water rises faster than it can flow forward, stacking into walls that advance along the shore. These waves, called bores, can travel miles inland, carrying with them silt, nutrients, and entire ecosystems. Fishermen time their work to the tides, knowing that to misjudge even by minutes can mean being stranded on dry ground or trapped by the returning flood. Resonant tides like these are sculptors as much as phenomena. The repeated surges carve valleys, deposit sandbars, and feed marshes that teem with life. Migratory birds flock to Fundy's mudflats, drawn by the feast of invertebrates exposed at low tide. The moon's gravity, translated through resonance, becomes an engine of renewal, a rhythm that not only shapes landscapes but sustains them. Without such motion, coasts would stagnate, losing their richness and their balance. Instead, the earth breathes through these tidal lungs, exchanging water, nutrients, and air in the same eternal pattern. Scientists studying Fundy and similar regions have discovered that resonance can change over time. As the moon drifts away from Earth and the continents shift, the tuning of bays and inlets alters. A perfect resonance might fade, weakening the tides, while another might emerge elsewhere. The planet's music is not fixed. It evolves slowly, note by note, over geological ages. The great tides of today are temporary, like all things, in brief crescendos in an ancient song that will continue long after the instruments themselves are gone. Yet to stand beside a place like the Bay of Fundy is to feel time condensed into rhythm. You can watch the water draw back until the seabed shines, the smell of salt and mud rising from its depths. Hours later, the same spot is beneath a heaving expanse of ocean. The difference between absence and abundance, between stillness and fury, is written in gravity's patient mathematics. The moon pulls, the bay answers, and the world transforms. Resonance reminds us that balance is not silence, it is motion in harmony. The moon does not shout to move the sea. It hums a steady note, and the earth responds where its shape allows. In those rare places where the frequencies align, the planet reveals what power lies hidden in rhythm. The tides surge and retreat. The coast breathes and reshapes itself, and for a brief moment, the ordinary pull of gravity becomes music. The moon's pull does not end at the ocean's surface. Its influence rises through the air, tugging faintly at clouds, at invisible currents of moisture, at the very breath of the planet. We often think of tides as belonging to the sea, but the atmosphere has its own tides too, slower, softer, harder to see. They move not with the crash of waves, but with the drift of wind and vapor. When the moon crosses overhead, the air swells almost imperceptibly, drawn upward by the same gravitational rhythm that moves the water below. And though we cannot watch it happen, the sky answers the ocean in kind, each breath mirrored by another, sea and sky bound in a single motion. At certain moments, this lunar touch becomes visible. Meteorologists have long noticed subtle patterns in rainfall that coincide with the moon's phases. When the moon is directly above or opposite, the chance of precipitation rises slightly, as though the atmosphere feels the same faint tug that lifts the tides. The difference is small, barely measurable, but it repeats with unwavering regularity. The moon changes the height of the oceans by meters and the height of the air by only a few centimeters, yet in that small displacement lies a quiet power. It can nudge clouds to rise just high enough to cool and condense, to turn vapor into rain. A few millimeters of pressure, a tiny shift in gravity, and the sky begins to fall. The effect reaches deeper than weather. It shapes humidity, temperature, even the way winds form and break. When the moon's pull aligns with the heat of the day, the atmosphere stirs more easily. When it drifts away, the air calms. In tropical regions, where the sea and sky are most tightly intertwined, these lunar patterns can set the pace of entire climates. Monsoon rains have been found to intensify with the full moon, their timing subtly tuned to the gravity above. Somewhere between ocean and air, the moon conducts an invisible symphony of motion. High above the Earth, where the atmosphere thins into the quiet of space, the moon's influence still lingers. Instruments aboard satellites detect fluctuations in air density that follow the same cycle as the tides. Twice each day, the upper atmosphere expands and contracts in a pulse synchronized with the moon's orbit. The energy from ocean tides is partly transferred into the air, rippling upward through layers of wind until it becomes a ghostly echo, a sky tide. The entire planet breathes in two directions, one through the water, one through the air, and both breaths are set to the same rhythm. To ancient observers, the connection between the moon and the weather seemed obvious. Farmers planted and harvested by its phases. Sailors read its shape to predict storms. Long before science found data to match intuition, the moon was treated as the sky's barometer, a companion to the changing winds. Modern instruments now confirm what they felt, that the atmosphere, though vast and restless, is not beyond the moon's reach. Its gravity touches the highest cloud and the deepest current alike. Even within our own bodies, the moon's pattern repeats. Humidity shifts affect the way scent travels, the way plants release pollen, the way animals behave before rain. Some species of birds adjust their migrations according to the moon's light and pressure cycles, sensing the weather it quietly manipulates. Humans, too, are tuned to it, though we've mostly forgotten. On nights of a bright full moon, sleep tends to come later and feel lighter. Subtle changes in air pressure and illumination register unconsciously, reminders of a rhythm we still carry within our skin. The moon's power over the sky is not loud or obvious. It does not summon storms or command the wind. It simply adjusts the balance, the delicate equilibrium between calm and motion. It reminds the atmosphere of its connection to the sea, and through the sea, to the earth itself. Every cloud that forms, every drop that falls, owes something to that balance, and to the slight, persistent tug of a distant world that never stops watching. If you look up on a humid night when the air is thick and the horizon glows faintly under the moon, you can almost feel it. The quiet coordination between above and below. The tides rise, the clouds gather, and the air itself seems to lean toward the light. Somewhere out over the ocean, invisible waves of pressure are passing through the sky, lifting it a fraction of an inch higher. The moon pulls on the water pulls on the air pulls on us. It is a chain of motion that binds every breath we take to the rhythm of the cosmos. The next time the wind changes just as the moon climbs, or rain falls beneath a clear, silver sky, remember this: the tides are not confined to the sea. They happen all around us, all the time, in air and light and heartbeat. The moon moves through it all, quiet and patient, turning the weather of the world as gently as a hand turning a page. Beneath our feet, the ground is never still. The earth rises and falls each day, though we cannot see it or feel it. Mountains shift by centimeters, valleys breathe in and out, entire continents flex like muscle under an unseen hand. It is the moon's doing. The same gentle pull that lifts the tides also stirs the rock itself. We are standing on something that moves, a world that bends toward its satellite and then away again, twice each day, in a rhythm as old as gravity. It is called the solid earth tide, and though it works in silence, its influence is everywhere. When the moon passes overhead, its gravity pulls not only on the oceans, but on the body of the planet. The Earth's crust, though solid and strong, is elastic on a planetary scale. It stretches upward, following the moon's path, creating a subtle bulge that can raise the ground by nearly 40 centimeters. When the moon drifts away, the land relaxes, sinking back into place. This swelling and settling happen continuously, all across the world, every hour of every day. If you could watch the planet from afar, it would seem to pulse, breathing, expanding, and contracting in sync with its lunar partner. The movement is too small and too gradual for our senses to notice. We do not feel the ground rise beneath us as the moon climbs into the sky, nor do we sense it settle when it falls below the horizon. But instruments do. High-precision satellites and laser measurements record this motion like the ticking of a clock. Bridges lengthen and shorten by tiny amounts. Tunnels bend imperceptibly. Even buildings lean and correct themselves as the crust shifts beneath them. Our world is not a rigid sphere. It is soft enough to be molded by lightless gravity, yielding just enough to remind us that nothing solid is ever truly still. This hidden tide does more than move stone. It stores and releases energy. As the earth deforms, heat is generated by friction deep within the crust. In the oceans, this warmth helps stir currents and influence circulation. In the mantle, it may play a small but persistent role in keeping the interior of the planet alive. Over millions of years, that steady kneading has shaped fault lines and volcanic regions, contributing to the slow rearrangement of continents. The same force that creates gentle tides at the shore also fuels, in its own quiet way, the restless geology beneath. The moon's influence is strongest along its path across the sky, but it is joined by the sun, whose gravity adds its own rhythm. When both align, their combined pull amplifies the Earth's response, making the ground rise a little higher. When they oppose each other, their forces cancel, and the motion weakens. These interactions are the solid Earth's version of spring and neap tides, written not in waves but in stone. The entire planet moves to the same rhythm, a double heartbeat of water and rock, light and darkness. In some regions, this lunar flexing is powerful enough to subtly influence earthquakes. When the moon's gravity reaches its peak, it can add just enough stress to trigger faults already on the edge of release. The timing is never exact, but patterns exist. A faint whisper of correlation between celestial alignment and seismic motion. The Earth listens, even if we do not. Its crust sways to the same music that drives the sea, its tension building and easing in the slow choreography of gravitational touch. It is strange to think that the moon, hanging so far away and shining so softly, holds the power to move not only water, but the very bones of the planet. The tides of the ocean are visible reminders of that connection. But the solid earth tide is the deeper truth, the proof that the entire world is pliant, alive, and responsive. When the moon rises, the land itself rises to meet it. When it sets, the land exhales, relaxing back into gravity's quiet equilibrium. If you stand outside on a clear night and feel the weight of stillness around you, remember that the stillness is an illusion. The ground beneath you is lifting, the crust arching upward in response to the same pull that stirs the waves. You are moving with the mountains and the plains, with the forests and the cities, a part of a planet that dances to the rhythm of another world. The moon does not speak, but it whispers through gravity. It calls to the earth in a language of motion, a dialogue without sound or interruption. Every rise and fall of the tide, every shift of stone, is an answer to that call. The world bends, the moon drifts, and together they continue their slow exchange. A whisper across space, repeated endlessly, shaping everything we know. The moon is not alone in its pull. Far beyond, the sun exerts its own gravity, vast and unwavering, tugging at the earth with a force that dwarfs all others. Yet distance changes everything. The sun's pull, though immense, acts from so far away that its effect on the tides is gentle compared to the moon's. Still, the two forces are never truly separate. They meet in constant dialogue, aligning and opposing, amplifying and easing. The tides are not the work of one partner but of two, locked in an elegant tension, a cosmic duet that plays across the oceans every day. When the sun and moon stand together in the sky, their gravities merge in harmony. The moon pulls the ocean upward, and the sun pulls in the same direction, their forces combining into a single, stronger tide. Water rises higher along the coasts, reaching further onto the land. These are the spring tides, named not for the season, but for the way the sea seems to leap upward, springing beyond its usual boundary. Twice each lunar month, during the new moon and the full moon, the alignment brings this crescendo, the tides swelling to their most dramatic expression. Then, as the moon continues its orbit, it moves to a right angle with the sun. Their pulls no longer cooperate but compete. The moon tugs one way, the sun another, each diminishing the other's influence. The result is the neap tide, a quieter pulse of the sea. The water still moves, still breathes, but its range narrows. The high tides fall short, the low tides rise a little higher, as though the ocean is holding its breath. In this alternating pattern of spring and neap, the earth experiences gravity as rhythm, a steady heartbeat written across the face of the world. From space, the interplay is beautiful. The earth's oceans bulge and flatten in overlapping waves of motion, one driven by the moon's smaller orbit, the other by the sun's distant path. The pattern looks like a dance, two invisible hands shaping the sea in alternating gestures of pull and release. Each month, the harmony and dissonance repeat, sculpting the motion of every coastline and bay. Some regions feel it more intensely than others, depending on their shape and latitude, but no place on Earth is untouched by this celestial choreography. When the moon and sun align, their combined gravity does more than move water. It also shifts the balance of the atmosphere, alters pressure systems, and subtly influences the crust beneath the seas. Spring tides are felt by everything the earth holds, not just by the waves that crash against the shore, but by the air above, the land below, and the creatures that live in between. Fishermen have long known the pattern by instinct, timing their work to the moon's phases. The strongest tides bring abundance, the weakest bring calm. Even now, satellites and tidal models confirm what ancient sailors read from the horizon, that the tides, like the stars, follow the laws of alignment. In every cycle, there is contrast, rising and falling, strength and stillness, harmony and opposition. The moon and the sun, though vastly different in scale, act together to maintain balance. Their combined influence keeps the Earth's rotation steady and its oceans dynamic. Without the sun's pull, the tides would lose their variation, the rhythm would flatten, and the seas would move with a monotony unknown to life. Without the moon, the sun's effect alone would be too diffuse, too distant to stir the same richness. It is the difference between them that makes the system whole. The alignment of these two bodies is not fixed. The moon circles the earth in an ever-changing ellipse, and the earth orbits the sun at a tilt, each revolution introducing slight variations in timing and strength. Sometimes the alignments coincide with perigee, when the moon is closest to earth, producing what we call super tides, water rising higher than at any other time. In those moments, gravity's cooperation is complete. The ocean climbs and retreats with breathtaking precision, as though bowing to both partners at once. To stand at the edge of the sea during a spring tide is to witness the universe at work. The moon's light stretches across the water, and somewhere beyond the horizon, the sun's gravity joins it. The tide surges forward, patient yet unstoppable, filling the air with the scent of salt and movement. Hours later, it will fall again, as the two great forces drift out of phase, returning the sea to its quieter pulse. The sun and moon do not compete so much as converse. Each shapes the other's influence, creating a pattern that is endlessly renewed. The tides are the record of that conversation, a reminder that balance does not mean stillness but motion shared. When the moon aligns, the oceans leap. When it drifts away, they rest. And through that endless cycle of unity and separation, the world turns, its waters carried by the gravity of two distant lights, forever in partnership, forever in motion. The moon is leaving us, not in any way we can feel or stop, but slowly, inevitably, as all things shaped by gravity must one day drift apart. Each year, The moon moves about 3.8 centimeters farther from Earth, roughly the width of 2 fingers. It's a quiet exhalation stretched across eternity, a gradual loosening of a bond that has held the planet in rhythm for billions of years. The cause is hidden in the tides themselves. As the oceans rise and fall beneath the moon's pull, friction between water and rock transfers energy from Earth's rotation into the moon's orbit. The seas tug against the continents, slowing the planet's spin by fractions of a second every century. In exchange, the moon is pushed outward, stealing a little momentum with every wave. It's strange to think that the same tides that cradle the shore are also engines of separation. The dance that gives the world its pulse is also widening the distance between its partners. Long ago, the moon was much closer, so close that it loomed larger in the sky, perhaps 3 times its present size. The tides it raised then were enormous, not the gentle rises and falls we know, but cataclysmic surges that swept far inland. The young Earth turned faster too, its days barely 5 or 6 hours long. The world spun like a child's top, unsteady and bright, while the moon circled close enough to paint the oceans with violent tides that sculpted coastlines and churned the shallows where life was beginning to stir. Over eons, the planet slowed. The moon drifted. Each century added a breath of distance, each million years a wider orbit. Now, at about 384,400 kilometers away, the balance feels steady, but it isn't permanent. The Earth continues to lose its spin, the moon continues to slip away. One day, if time stretches far enough, the two will reach equilibrium. Earth's rotation will match the moon's orbit, and both will become tidally locked. The same side of the Earth will always face the same side of the moon. The tides will quiet, the oceans will move more slowly, less boldly. The world will turn once every lunar month, a planet and its satellite caught in perpetual gaze. But that is billions of years away. For now, the moon's departure is almost imperceptible. Only the most delicate instruments, laser reflectors left by Apollo missions, can detect it. Scientists bounce beams of light off mirrors still sitting on the lunar surface and measure the return time down to milliseconds. The results reveal a universe of motion too slow for the eye. The moon, faithful companion of the night sky, is not fixed. It is receding into the dark, following a trajectory written by physics but felt by poetry. The effects of that drift ripple through more than space. As the moon moves away, Earth's days lengthen. It's a subtle change, just milliseconds over centuries, but compounded across deep time, it reshapes the rhythm of the planet. When the first coral reefs formed, the day was about 22 hours long. When the dinosaurs roamed, it was closer to 23. The modern 24-hour day is only a temporary configuration, a compromise between celestial forces. Somewhere in the future, the day will stretch to 25 hours, then 26, as the spin that once flung continents and storms begins to slow further. Time itself, as measured by the turning of the world, is elastic, drawn out by the tide's resistance, sculpted by the moon's retreat. And what happens to the oceans in this slow rearranging? As the moon recedes, its gravitational pull weakens and the tides will diminish. The difference between high and low water will grow smaller. Coastlines will flatten, and the great surges that now mix and oxygenate the seas will fade into gentler motions. The heartbeat of the ocean will slow. Marine ecosystems that depend on the energy of the tides, the pulsing flows that stir nutrients and shape habitats, will adapt or fade. Life will find new rhythms, but the world will be quieter for it. It's easy to forget that this relationship, this balance between spin and pull, is temporary. The moon has always been our constant companion, rising over every generation that ever lived. Yet it was once part of Earth, born from collision and fire, and one day it may drift too far to be bound. Long before that, the sun's own changes will overtake everything. But for now, We live in a rare, perfect moment when the moon's distance creates tides that breathe life into the planet, yet not so strong as to tear it apart. Stand by the ocean at night, and you can feel that balance. The waves draw back, pause, and return, each one carrying the whisper of that invisible connection. Above you, the moon climbs its silent path, tugging at the water, the land, and even your blood. Every tide is a message sent across 384,000 kilometers of space, a reminder that motion, even the smallest kind, accumulates. The moon may be drifting away, but its influence remains, shaping every shoreline, every creature, every moment of time. And as it moves outward, the earth sighs softly, giving up a little of its spin, a little of its speed, in exchange for distance. It is the price of balance, the cost of beauty, the slow, graceful parting of worlds that once shared a single fire. Long before compasses, clocks, or satellites, humanity looked to the horizon and saw rhythm. The sea rose and fell with a predictability that seemed divine, a pulse the world itself obeyed. The moon's pale shape above the water became more than a light in the sky. It was a signal, a companion, a god. People didn't need to understand gravity to know that something in that glowing sphere commanded the ocean. They could see it with their own eyes, hear it in the crash of waves, feel it in the pull of boats at their moorings. The tides were language, and early civilizations learned to read them long before they learned to write. In the islands of the Pacific, far from the continents, the tides were both map and teacher. Polynesian navigators crossed thousands of miles of open ocean, guided by the moon's position, the color of the water, the tilt of the swell. They understood that when the moon was full, the sea moved differently, that the currents changed direction and the depths breathed in time with the sky. They did not measure time with hours but with motion. The rise of the tide, the length of the wave, the pattern of stars mirrored on the dark water. The moon was a compass that did not falter, its gravity shaping not only the ocean, but the very possibility of exploration. Without it, the vast network of islands might have remained isolated forever. Along distant shores, other cultures made their own reckonings. On the coasts of Britain, where the Atlantic tide surges in grand sweeps, ancient builders raised stones that caught the light of the moon at precise intervals. Stonehenge and other megaliths may have marked not only the solar year, but the lunar month, the dance between sun and moon that governed agriculture, migration, and ritual. The sea's rhythm was the first calendar, its cycle as reliable as breath. When the tide retreated, people gathered shellfish and harvested salt. When it rose, they fished and sailed. The moon's pattern became the clockwork of survival, written into myth as gods and goddesses who ruled the waters. In Mesopotamia, early astronomers tracked the moon's phases on clay tablets, linking them to the flooding of rivers and the fertility of crops. The Sumerians built their months around the moon's waxing and waning, naming days after its visibility in the sky. Even inland, far from the coast, they sensed the connection. The way the world responded to the moon's pull in rhythms of growth and retreat. To them, lunar cycles were not abstract. They were the heartbeat of time itself, the measure by which life advanced. In Egypt, the moon was Thoth, god of wisdom and writing, the keeper of order who balanced chaos through cycles. Along the Nile, though the river's floods came from rain far to the south, people still linked its timing to the moon. They watched for omens in the brightness of its light, believing it carried messages from the gods. Farmers planted and harvested by its phases. Sailors waited for certain moons to ride the river's flow. The moon was not only a force of nature, it was an authority, the embodiment of predictability in a world that could turn violent without warning. The farther north you travel, the more dramatic the tides become, and with them, the reverence deepens. Norse mythology spoke of tides as the work of giants imprisoned beneath the sea, their breath pushing and pulling the waters. In Japan, The Shinto tradition saw the moon's reflection on the waves as a pathway between the mortal and the divine. Across the world, stories emerged from observation. When the moon grew fat, the fish returned. When it disappeared, storms followed. The sea's behavior was a dialogue with the sky, and humanity became fluent in its language long before science gave it names. What's remarkable is how precise those ancient understandings were. Polynesian navigators could detect islands beyond the horizon by reading subtle shifts in wave interference, tides refracted by distant land, stone circles aligned with lunar standstills, predicting rare events that repeat only every 18.6 years, an accuracy that rivals modern astronomical knowledge. The moon shaped not only culture, but cognition itself. It taught us to notice patterns, to count days, to look upward and connect motion in the heavens with movement on Earth. The tides made thinkers of us, philosophers and astronomers born from the sea's edge. Even now, in the age of digital time and atomic clocks, the lunar calendar lingers. It governs Ramadan, Passover, and the Chinese New Year, weaving ancient astronomy into modern ritual. The tides still decide the rhythms of fishermen, the feeding of seabirds, the breathing of coral reefs. Our ancestors did not worship the moon out of ignorance. They did so out of recognition. They knew that the glow above and the surge below were one story, written across both sky and water. To stand by the ocean today is to feel that same inheritance. The tide approaches and recedes, whispering in a language older than any nation or word. Somewhere, far out of sight, the moon hangs above the curve of the world, pulling softly, endlessly, like a memory that refuses to fade. We are descendants of that rhythm. The moon guided our migrations, marked our time, shaped our myths, and even now, as lights on our cities drown its reflection, it continues to move us, patient, deliberate, forever in conversation with the sea and the people who still listen. If you stand by the shore at night, when the moon hangs low and the tide is turning, you can hear it, the world humming to itself. It's a low, endless sound, not made by any one wave but by the sum of them all, colliding, retreating, breathing. The sea is full of music, though it's not written in melody or measure. It's the sound of gravity translated into motion, of water made voice. And though the human ear can only catch fragments of it, the ocean's rhythm is shaped entirely by the pull of the moon. Every tide is a phrase, every cycle a song. When the tide rises, the ocean's surface stretches, its pressure changing across thousands of kilometers. The movement is too slow for us to notice, but it creates a kind of resonance that vibrates through the water column and into the seafloor. Hydrophones, underwater microphones, record this as a faint oscillation, a heartbeat that repeats twice a day. Scientists call it the hum of the earth, a constant vibration caused by waves driven by tides, pressing and releasing in synchrony with the moon's orbit. It's not sound in the ordinary sense, but a vibration of the entire planet, a note so deep it falls below hearing, yet it never stops. In certain bays and inlets, where the shape of the coast matches the rhythm of the tide, this resonance becomes music in the literal sense. The water sloshes in and out like air in a flute, building pressure that creates infrasonic tones, pulses that travel for miles beneath the waves. The Bay of Fundy, famous for its towering tides, also sings in these deep frequencies. Each time the water surges into its narrowing channels, it compresses the air and water inside, releasing energy as a slow, rolling sound that moves through both sea and land. It's a tone that no single ear can hear in full, but marine mammals can. Whales, in particular, are drawn to these frequencies, their own songs overlapping with the tidal rhythms, as though they're joining an ancient orchestra. The moon writes the score, but the ocean performs it differently each day. When the tide retreats, the waves break against rocks, cliffs, and reefs, and every impact produces its own pitch. Small bays create higher tones, long open shores resonate lower. Together, they form a soundscape that changes with the phase of the moon as the strength and timing of tides alter the sea's percussion. To a human listener, this might sound like randomness, waves crashing, wind rushing. But to the ocean itself, it's order, a rhythm born of celestial timing. Even the bubbles formed in the crest of a wave produce sound, ringing like tiny bells as they collapse. The sea is an instrument of impossible scale. Pressure waves from tides travel through the deep, bouncing off ridges and trenches, layering on top of one another until they form standing patterns. These can last for hours, sometimes days, building harmonic fields that marine animals use to orient themselves. Fish, crustaceans, even plankton respond to these vibrations, sensing the changing frequencies as signals of the moon's phase. Coral polyps release their eggs during specific tidal harmonics, cued by the same sounds that echo through their reef homes. Life beneath the waves doesn't just move with the tides, it listens to them. The moon's touch reaches into every note. During spring tides, when the sun and moon align, the sea's music swells. The increased range of motion deepens the underwater tones, turning calm coasts into resonant chambers. In neap tides, when their forces oppose each other, the ocean quiets, the baseline softens, the rhythm slows. The world doesn't go silent, it simply changes key. Somewhere between these extremes lies a steady pattern, a subtle alternation that has persisted since before life began. We are latecomers to this concert. Long before humanity invented instruments, the earth was already singing. The moon has been the conductor, its gravity dictating tempo and amplitude. The ocean, its orchestra, vast and patient. What we call noise is, in truth, structure, the physical manifestation of rhythm on a planetary scale. Even the wind above the sea, shaped by differences in temperature and tide, carries the same pulse, the same recurring beat that links air and water to the same source. If you could strip away everything but the sound, the wind, the surf, the echoes through rock and silt, you would hear the heartbeat of a world in motion. The moon circles, the ocean rises, and the sound begins again. It has been playing for 4.5 billion years. Not one moment of silence, not one pause. Every tide you've ever stood beside is just a single note in that endless composition, the sea's response to the moon's call. And when you stand there, feeling the vibration of the surf beneath your feet, you are part of it too. The air in your lungs, the water in your veins, the pulse in your wrist, all moving in rhythm with something ancient and unbroken. The moon pulls the sea sings back, and the earth listens. That is the music beneath the waves, the sound of connection, soft and eternal, written in gravity and time. From above, the ocean looks still, a seamless blue stretching across the curve of the planet. But to the eyes of satellites, it is alive with motion. The surface of the sea is not flat. It ripples, rises, and dips in ways too subtle for human senses. Each undulation, measured in millimeters, holds the imprint of forces below. The moon's pull, the shape of mountains buried in darkness, the slow movement of currents, all leave their fingerprints on the ocean's skin. From orbit, those traces form a hidden map, an invisible architecture of the world's largest and least known landscape. The technology that reveals it is called satellite altimetry. Beams of radar bounce from space to sea and back again, measuring the time it takes for the signal to return. The delay, barely fractions of a second, tells scientists how high or low the surface lies. When compiled over years, these readings expose a pattern. Tiny bulges where underwater mountains rise, shallow dips where trenches sink. The ocean's surface, it turns out, mirrors the contours of the seafloor. Gravity from hidden ridges pulls the water upward by mere centimeters, while deep basins allow it to fall. What looks like flatness from the shore is, on a planetary scale, a shifting sculpture, shaped by unseen terrain. Beneath the Pacific alone, satellite maps have revealed thousands of seamounts that no human eyes have ever seen. Some tower higher than Mount Fuji, yet remain drowned in blackness, their presence betrayed only by a soft swell in the sea above. These hidden mountains form highways for currents, redirecting the flow of heat and nutrients that sustain life. They guide the great migrations of whales and the upwelling of plankton that feeds them. The tides interact with these features, amplifying or calming the ocean's pulse, carving channels that have existed for millions of years. Each passing wave, shaped by lunar gravity, feels the contours of those submerged forms, tracing their outlines in silence. The moon, though distant, plays a part in this invisible architecture. Its pull drives tidal currents that scour the sea floor, redistributing sediment and sculpting ridges with the slow precision of a craftsman. Over time, these flows etch grooves into continental shelves, deepen canyons, and build underwater dunes taller than skyscrapers. The process never stops. It's as though the moon is carving the earth from afar, one tide at a time, each surge polishing the face of the deep. And above it all, the ocean's surface adjusts, rising slightly over mountains, sinking over valleys, a delicate balance between gravity, motion, and memory. For centuries, the seafloor was the last great unknown. Early explorers mapped coastlines but could only guess at what lay beyond. They called it abyss, chaos, mystery. Now, thanks to satellites orbiting hundreds of kilometers above, the ocean's hidden geometry is unfolding in astonishing detail. Yet what we see is not just geography. It is the story of gravity made visible. Every rise and fall, every slope and curve, is a translation of how mass and motion interact. The moon, the tides, the crust, and the water are locked in conversation, their dialogue recorded in the shape of the sea. In these maps, beauty takes the form of precision. You can trace the mid-Atlantic ridge winding like a scar through the ocean's heart, or see the deep trenches off Japan, where tectonic plates slide beneath one another. You can find the faint circular bulges that mark ancient volcanoes, long extinct, but still tugging gently at the water above. The level of detail is astonishing. Changes in sea height, measured to within a few millimeters, enough to detect shifts caused by storms, melting ice, even the weight of rainfall across continents. The Earth breathes through these movements, and satellites capture every exhale, and yet, for all our technology, the full depth of the sea remains mostly unmapped. The satellites can sense shape but not texture, outline but not life. What they show us is a ghost of the real thing, a shadow of ridges teeming with creatures that glow, plains crossed by rivers of current, mountains echoing with whale song. The invisible architecture is both revelation and reminder that the world still holds mysteries vast enough to humble us, written in millimeters of motion. At night, when the moon's reflection shivers across the ocean's surface, it is easy to forget how much lies beneath. But the light you see, trembling on the waves, is following contours sculpted by gravity itself. Each glint is bent slightly by the bulges and dips of the sea, refracted through the topography of an unseen world. The moon pulls the water upward, the earth pulls it down, and between them, they shape the face of the planet. The satellites keep watch, silent witnesses to this eternal choreography. They trace the moon's influence, the earth's breathing, the tide's ceaseless sculpting, and they show us that even the calmest surface hides movement and design. The ocean is not flat. It is alive with structure, its stillness an illusion. Beneath it, the planet's hidden bones wait in the dark, shaping the world above, drawn and redrawn every day by the gravity of a distant moon. The moon has always been a mirror, reflecting not just sunlight, but something of ourselves. For as long as humans have watched it rise, they've felt it doing something to them, some faint tug beneath the skin. The ocean answers the moon's pull openly, with tides that rise and fall like breath. We, being smaller seas, hold our response in silence, but perhaps not entirely. Our bodies are mostly water, our hearts and cells attuned to rhythm, our sleep and hormones governed by cycles that echo those above. Whether it is myth or memory, the idea that the moon stirs something within us has never left. Inside the body, fluid moves constantly, blood, lymph, cerebrospinal tides washing through the brain. These are not static systems but pulsing oceans, each driven by pressure, heartbeat, and subtle forces of alignment. Scientists have long asked whether the moon's gravity, strong enough to lift entire seas, might exert an echoing influence here. The physics say its direct pull on a human body is infinitesimal, no greater than that of a nearby building. But the body does not live by force alone. It lives by rhythm, and the rhythms of the moon, precise and unending, have a way of whispering into the patterns of life. Our circadian clocks, those intricate molecular gears that regulate wakefulness and rest, are tuned primarily to sunlight. But layered atop that solar rhythm is a quieter, slower one, the lunar cycle. Studies have shown that sleep duration, melatonin levels, even body temperature fluctuate slightly in sync with the moon's phases. On nights of a bright full moon, people tend to fall asleep later, sleep more lightly, and dream more vividly. Whether it's the extra light or an ancient biological imprint, no one knows for certain. Yet the pattern persists across cultures and species, as if some deep memory of lunar time still hums beneath the modern world's electric glare. In coral reefs, that rhythm is unmistakable. Entire colonies of coral spawn in mass synchrony, releasing clouds of gametes into the water precisely aligned with the full moon. The event is so exact it can be predicted to the hour. Sea turtles climb beaches guided by lunar light, their migrations governed by its phases. Crabs, fish, and plankton rise and sink with the tides in unison, obeying a timing older than instinct. Life learned to breathe in time with the moon, and though we've drifted far from those original waters, the pattern remains in our physiology. The moon's influence on emotion has always been harder to measure, but harder still to dismiss. The word lunacy comes from Luna, the Roman goddess of the moon, and for centuries people believed that full moons brought madness. Hospitals recorded spikes in agitation, sleeplessness, even violence. Modern data finds no consistent proof, but the myth lingers because it feels true. Anyone who stayed awake under a full moon's glare knows its peculiar charge, that eerie alertness that hums through the air like static before a storm. It's not that the moon causes chaos, but that it draws attention to what already stirs beneath the surface. It reminds us we are still animals who feel cycles in our bones, even when logic insists otherwise. In women, the connection between lunar and biological cycles is the most intimate and enduring. The average menstrual rhythm, about 29.5 days, mirrors the moon's orbit almost exactly. Whether coincidence or coevolution, the parallel has shaped mythologies across millennia. In ancient China, the moon was the emblem of fertility and renewal. In Greece, Artemis ruled both the hunt and the womb. Some modern researchers suggest that before artificial light, menstrual cycles were more likely to synchronize with the moon's brightness. Ovulation peaking around full moon, bleeding at new moon, aligned with the tides of darkness and light. The theory remains debated, but it feels like something the body would remember even if the mind forgets. What's certain is that the moon continues to guide the subtler motions of our lives. Farmers still plant by its phases. Fishermen still read its rise before setting nets. Surgeons schedule certain procedures by the lunar calendar, not from superstition, but from observation. Some wounds seem to heal faster when the moon is waxing, when tides within and without are rising. Perhaps these are coincidences stacked over time, or perhaps they are reminders that the same forces moving oceans also move us, even if the movement is too small to measure. At night, when the moon climbs high and the world feels hushed, there is a reason you feel awake, a reason your thoughts seem to wander farther, your heartbeat to slow or quicken without cause. You are a tide contained within skin, swayed not by belief but by belonging. The moon does not command you, but it invites you into rhythm, the slow, ancient music of gravitational pull and living water. You are, in some quiet way, an ocean too. There was a time when the moon filled half the sky. It hung enormous and golden, so close that its craters could be seen in breathtaking detail, so near that its gravity reached into the bones of the planet and pulled. The young Earth spun faster then, turning through a day in barely 6 hours, and each spin brought a tide that was nothing like the gentle rise and fall we know now. The seas surged hundreds of meters high, walls of water racing across the continents in slow, thunderous motion. The planet was still molten in places, still raw and forming, and above it all, the moon was a relentless sculptor, shaping oceans, crust, and air with its impossible nearness. Scientists can trace this intimacy through the fossil record of tides, locked in ancient sediments like the grooves of a forgotten song. The patterns show a faster rhythm, a world moving to a quicker beat. The moon, newly born from the collision that tore it from Earth, orbited at less than 1/10 of its current distance. The gravitational pull between the two bodies was immense, locking them into a dance so violent it nearly broke them both. Every tide was an act of creation and destruction. Water crashed across the coasts, eroding rock, spreading minerals, and carving the first true shorelines. The energy released by those tides was staggering. Friction between ocean and crust turned kinetic motion into heat, helping to keep the planet's mantle molten. The constant kneading of rock beneath the sea altered the chemistry of the water, dissolving metals and minerals that became the ingredients of life. In the shallows left behind by retreating tides, pools of warm, mineral-rich water steamed beneath the light of a vast, alien moon. It was there, many scientists believe, that life began. Molecules met and bonded in the rhythm of rising and falling seas, tested by cycles of evaporation and renewal. The first cells may have taken their breath in time with the tides. The moon's proximity gave the Earth its first balance and its first instability. Its gravity stabilized the planet's tilt, taming the chaos of its early spin. Yet at the same time, it drove tides so massive they sculpted the continents anew. Volcanoes erupted more frequently under the shifting pressure. Whole regions of crust flexed and cracked in response to the moon's pull, birthing mountain ranges and ocean basins. The air itself changed with the tides, as gases were released from deep within the Earth, feeding an atmosphere that would one day cradle breathing life. Night under that ancient moon must have been unlike anything imaginable now. The world glowed with reflected light so bright that darkness never truly fell. The tides rose and fell so dramatically that coastlines moved by miles each cycle, exposing vast mudflats that steamed and shimmered under lunar fire. These were the first laboratories of evolution, unstable, ever-changing, yet perfect for experimentation. Life that survived here learned flexibility, resilience, and rhythm. It learned to move with the moon. Over millions of years, the moon drifted away, carried outward by the very tides it created. Each surge transferred a little energy from the spinning Earth to the orbiting moon, pushing it farther and farther from its parent. As it receded, the tides softened, the oceans calmed, the planet's day lengthened. The world we know, the one of predictable rhythms and gentle coasts, was born out of that slow separation. But echoes of that closeness remain. Every tide, every heartbeat, every cycle of sleep still carries its signature, faint but enduring. The ancient Earth was not a quiet place. It roared with wind and heat and water, its surface reshaped daily by the moon's command. Yet from that chaos came stability, and from that violence, life. When we look at the moon today, distant, serene, a pale coin in the sky, it is easy to forget what it once was. A blazing neighbor, a sculptor of worlds, a force that stirred the oceans into motion and gave time to the planet below. The moon has been moving away for billions of years, but in every tide that reaches the shore, it is still speaking to us. It says, "Remember when I was closer?" And if you listen closely enough, the ocean still answers. Someday, the tides will stop. The moon will have drifted so far that its pull can no longer stir the oceans, its influence too faint to lift even a ripple. The seas will lie still beneath the sky, vast and unmoving, like glass stretched to the horizon. The moon will still shine, but its bond with Earth will be broken, its long work complete. And though that day is billions of years away, the motion toward it has already begun. With every tide that rises and falls, the moon slips a little farther from us, a few centimeters each year, carried outward on the energy it has stolen from the spinning Earth. The separation is so slow it cannot be felt, yet as certain as gravity itself. It is the rhythm of farewell. The Earth will not stop turning, but it will turn more slowly. Days will lengthen until each one matches the length of the moon's orbit. The planet will spin once for every time the moon circles it, the same face of the Earth, always looking up at the same face of the moon. The tides, once fierce, then gentle, will fade to nothing. The ocean will no longer breathe. Its currents will move only by the push of wind and heat, its heartbeat silenced. Life, if it still exists, will live in still water, beneath an unchanging sky. The moon's journey outward is not an act of abandonment. It is the inevitable result of love expressed through physics. The two bodies have shared energy for 4.5 billion years, exchanging it in the form of motion and gravity. Every wave that has ever touched the shore has been part of that exchange. The tides slow Earth's spin just enough to send the moon outward, and in that slow transfer lies a story of balance. The moon's departure is written into the same equations that once bound it to us. Creation and loss are not opposites. They are the same motion, seen from different points in time. Even as the moon retreats, its influence endures. It has given the Earth its rhythm, its stability, its seasons and cycles. Without it, the planet might still wobble chaotically, its tilt drifting from one extreme to another. Without tides, the coastlines that nurtured the first cells might never have existed. The moon shaped the conditions for life, then stepped back, allowing the world it helped create to grow. Its distance now is a kind of mercy, a letting go that sustains the delicate balance of oceans and air. One day, far beyond the reach of any memory or name, the sun will expand, bright and red, swallowing the inner planets. The Earth and moon will likely vanish together, their long dance ending in fire. But before that final moment, there will come an age of stillness, when the seas no longer rise to greet the sky. When the night is silent and unmoving, it will not be tragic. It will simply be the end of motion. The same forces that began the tides will one day bring them to rest, completing the circle they started when the moon first tore itself from the newborn Earth. It is easy to think of that future with sorrow, to imagine the absence of waves as a kind of death. But perhaps it is better understood as fulfillment. The tides are not endless. They are the sound of a bond in motion, a conversation between two worlds. Every ebb and flow is part of a long goodbye. The ocean's restlessness, its constant rising and falling, is how the Earth remembers the moment of creation, the pull of something once close, now forever moving away. Tonight, the moon still hangs above the water, and the tide still moves. The waves climb the shore, pause, and retreat, whispering over the sand as they have for billions of years. The light on the water trembles, reaching toward its source. Everything you see in that shimmer is impermanent. The pull, the glow, even the silence between them. Yet, within that impermanence lies the miracle of now. For this brief moment in the history of the universe, the distance is perfect. The moon is far enough to orbit gently, yet close enough to move the seas. Its size in the sky matches the sun's, so that when it passes before it, the two align in a perfect eclipse. This balance, this fleeting equilibrium of motion, mass, and light, will not last forever. But it exists now, and that is enough. The tides still rise, the moon still calls, and though it is leaving, it will take billions of years to say goodbye. Until then, the ocean will keep answering, carrying the echo of that conversation across every shore, every lifetime, every breath. The moon drifts, the water moves, and for now, the world still sings.